Hey, grade nines. Okay, page 328, number 19. Gonna do a similar question. Okay. Keegan walked from his home to his friend Ryan's house at 4.8 kilometers per hour. When Keegan returned home along the same route, okay, we're saying the exact same route. Yes, I probably in real life that's literally impossible, but whatever. Keegan returned along the same route. He strolled at 3.2 kilometers per hour, so Keegan went slower on the way home. Keegan took a total of 50 minutes to walk to Ryan's house and back again. Okay, so question 8. How many minutes did it take Keegan to walk from his house to Ryan's house? Okay, and how far is it from Keegan's house to Ryan's house? Okay, so I've done a little bit of setup here. Do you like this house? Beautiful. Keegan went to Ryan's house, then he went back, okay, and he did the exact same route. So in other words, if it were, just to exaggerate, if it were 200 kilometers to Ryan's house, it was 200 kilometers back. Obviously, it's going to be far less than that. I'm just going to pause here for a sec, and I'm going to contemplate this a little bit because I want to make sure I can set this up in a relatively straightforward manner. Okay? See you in a sec. Okay, I'm back. I just want to check a few things there. So let's talk about this problem for a second. So Keegan goes this distance to Ryan's house, and then he goes the exact same distance back. So let's just call this the distance there. So the distance there. And we'll call this the distance back. Okay? So remember, he took the same route. And so let me just pause for a sec and let's just talk about what do we mean with distance, right? Distance is composed of knowing what? Well, you have to talk about something like alongside the, a concept of speed. You ought to know how far you're traveling. So, I mean, in terms of time, okay, how long you're traveling for. I should have said how long instead of how far. And of course, distance does deal with how far. Okay? So, in other words, let me point out something to you. Again, they assume that you know this relationship, that the distance someone or a car or a train or a plane, bus, whatever, travels, it's a matter of its speed times time. So here's this very simple example. Mr. Smith went on one of his long Sunday drives, and he was traveling 100 kilometers per hour. Now, if I did that for 12 hours, like I kind of almost did, how far did I go? Well, I must have gone 1,200 kilometers, right? And the units always work out, right? I didn't leave enough space here, but the speed is always given as kilometers per hour. And I went for 12 hours, and actually these units would actually cancel out. I could do a whole lesson on that. But anyways, what you're left with is 1,200 kilometers. In other words, D, the distance D is equal to how fast someone is going and how long they go for, right? If I were traveling 100 kilometers an hour and I only went for 2 hours, well, then I went 200 kilometers. Okay? I'm going to pause again and erase this. Okay, so I just wanted you to understand that this problem is tough to do if you don't already know what the relationship is between these concepts of distance, speed, and time. Here's what I think we should do. Okay, I think we should just do another T-chart. Okay, let's talk about the speed there. Okay, and the speed back, and then how long it took to get there, and how long he took to get back. Okay, so let's call this side of the equation there. So in other words, he was going there. Keegan was going to Ryan's house, and he went back. Okay. So on the way there, let's talk about his speed. His speed was 4.8 kilometers per hour. Do we know how much time it took? No, we don't. So why don't we give this variable, why don't we give the time in x? So in other words, let the time equal x. And the distance, well, let's just wait on that for a second, okay? Let's just wait. Let's talk about back now. All right. So the speed in which he was going back was 3.2. And I know I made a little bit of an boo here. So That's a real word, by the way. Ubu boo boo. Um, oh, shoot. I want to do this in green. Trying to be consistent, ladies and gentlemen. Okay, so sorry, speed is always given in kilometers per hour, meters per second, whatever. But it has to be something per something. It has to be a unit of distance versus a unit of time. Okay, now watch this. How much time did Keegan need to come back? We don't know that either. But here is an extremely important piece of information. It took a total of 50 minutes to walk to Ryan's house and back again. So little miniature T chart. Let's forget the speed. So there's there and back. Keegan is Superman. He took 1 minute to get to Ryan's house, and then he crawled back like a sloth. If the total amount of time it took him was 50 minutes, and he took 1 minute to get there, and he must have taken 49 minutes to get back because the total is supposed to be 50. Conversely, if he took, 25 minutes to get to Ryan's house, well, then he must have taken 25 minutes to get back. But that would assume he was going the same speed. So we know that's not true. And I'm sure he's not Superman. So that's not true. But what I'm saying to you is the time it took Keegan to come back is going to be equal. See, this is where your nice complex expression comes in, is 50 minutes minus this x, right? So if this x was 10 minutes, then look, 50 minus 10 would be 40. Okay, if x were to equal 12, if he took 12 minutes to get there, then 50 minus 12 is 38. He must have taken 38. So this expression, this one allows for the different speeds. So for different speeds, that's the beauty of, and that's sort of the secret of this question. When you define the time going there, and then you're able to relate. Remember, I talked about relating stuff. What is the time that Keegan, when he went back this way? Well, how much time did he take? He took 50 minutes minus the time he took to get there. So if he took 15 minutes to get there, then he must have taken 35. If it was 15 to go here, to go to Ryan's, then it must have been 35, right? And that allows that, obviously, he's on one hand, he's walking faster. Now, we know this is not true. In fact, this should be the higher number, and this should be the lower number. No, pardon me. I had it right before. Okay, this should be the higher because he's walking slower. So yes, he needs more time. All right, let me just erase all that now. Okay, so just going to pause here for a sec. Hang on. Okay, sorry about that. All right, so what I'm saying to you is the faster he goes there, the faster you go, the less time it takes. I guess that's the way I'm trying to say it. The faster you go, the less time. Okay? And yes, I know less is supposed to have two S's. And here he went slower, so this is more time. In other words, this is definitely not a 25-minute split. And this expression allows for it. Now, what was the distance? Well, this is an interesting thing. You don't need to know. You don't need to know right now what the distance is, because if you look at it from this point of view, okay, I'm just going to write there. I'm just going to make this a little bit bigger. Okay, so the distance to go to the house, right? The distance to go there is equal to the distance back. So we don't have to worry about distance right now, because distance, this is why I did this review, distance is defined by speed and time. So we can wait until later, right? Because I know some of you are saying, wait a sec, Mr. Smith, I don't know the time it took and I don't know the distance. And I'm saying that's okay for now, because you can deal with one variable at a time. Because distance can be defined as speed times time, and because the distance there is the same as the distance back, for the time being, we don't have to worry about the distance. We can answer that question later. Let's put this all together. So he went 4.8 kilometers per hour for how many minutes? No idea. And on the way back, he went slower. And so how long did that take him? No idea. But I do know I do know that whatever time it took here, I'm going to have to subtract it from 50. 50 is the maximum amount of time that it took for him to go there and back. Okay, that total was 50. I don't care how it splits up. It could be 19 and 31, whatever. But now we have an equation. This is the happy moment. Okay. All right, I'm going to pause once again, and I'm going to erase so I can do the question. I can actually do the number crunching. Okay, be right back. So we have 4.8 x is equal to 3.2. So this ends up being a distributive property question. That's the bottom line, okay? The distance he traveled there is the same as the distance he traveled back. And since distance is a function of speed times time, speed times, this is an expression for time, you can equate these two, okay? So let's do the distributive property first, okay? So we have, sorry, I'm just gonna get this out of the way. 3.2 times 50 is 160, okay? And 3.2 times 1x, so minus 3.2 times x is 3.2x. And of course, we didn't really do much over here. We didn't need to. We were waiting for this distributive property to sort itself out, okay? So why don't we add, we're subtracting a term that has the variable. So why don't we just add it to both sides? This is already kind of lonesome and by itself and relatively isolated. So why not take advantage of that? There's no constant on this side. So I feel it's an advantage to add 3.2x to both sides. This will zero itself out. An awesome thing, of course. And 3.2 plus 4.8 is equal to 8x. And look, this worked out really nicely. We got nice whole numbers. Divide both sides by 8. Divide both sides by 8. And x is equal to 20. Okay? All right, so 20. I'm just going to erase a little bit more. It's tough to pause when a pause button comes up. There's a big box that blocks a lot of this stuff. So I just got to do this live and rock and roll. Let's check this answer. Okay. How many minutes? Well, to go there, we were saying it took him 20 minutes. Let me just change the colors here. 20 minutes. If that's true, and of course he was going slower, it makes sense that if x is equal to 20, well, he must have taken 30 minutes to go back from Ryan's house. Right, that makes sense. When you're traveling faster, you need less time to go the same distance as when you're traveling slower. So he went faster here, so that means less time. He went slower on the way back, so this should work out. Let's check it. So 4.8 times 20 minutes is equal to 3.2 times 30 minutes. Now again, where did I get the 30? I did 50 minus 20, right? 50 minus, we already ate up. We've already eaten up 20 minutes going to Ryan's house, and we're going slower. So hopefully it takes longer than 20 minutes. And yeah, it took 30 minutes. Okay, 4.8 times 2, well, that's equal to 96, okay? And 3.2 times, 30, that's also equal to 96, okay? Now, this is the trickiest part, I think, in the whole section, the whole chapter, okay? Because do you really think it's 96 kilometers to Ryan's house? No. What's the problem? The time, okay, the time is weird, okay? Now, I'm saying to you, I verified the equation, I got the same numbers. So I am convinced it was 20 minutes and it was 30 minutes. The problem is speed is done in terms of kilometers per hour, not kilometers per 10 minutes, 5 minutes, 50 minutes. So what I'm saying to you is 20 minutes okay? 20 minutes is really 20 minutes out of a 60-minute hour. I don't know why my pen is so whack right now. In other words, it's 1/3 of an hour. And of course, half an hour, 30 minutes, did you hear the language I used? Is half an hour. So let's recheck this with the real numbers, the hidden fractions, okay? I know this is a lot, grade 9s, but, hey, bear with it. So 4.8 times 1/3 of an hour. I'll say that again. 1/3 of an hour. If I could just properly draw a 3 here. 20 minutes is 1/3 of an hour. I'll say it again. 20 minutes is 1/3 of an hour. That should be the same equivalent as going 3.2 kilometers per hour for half an hour. Okay? By the way, this wasn't a mistake. I did this on purpose because I wanted to throw you for a loop. Okay? I did want to put in 20 minutes because I wanted to remind you, especially for high school and all you kids going into science and math and physics and bio and chem, remember that time is weird. Okay? This speed was in hours, kilometers per hour. This was in minutes, and you had an absolute mismatch. This is a speed given in kilometers per hour. I'm not going to write the kilometers because that's not the mismatch. And my answer was in minutes. And this is no good. You have to convert your minutes into a fractional hour. Fractional hour. And 1/3 here is 1.6. And 1/2 of 3.2 is 1.6. My friends, that is, oh my gosh, 1.6 and 1.6. Whew! That's the real distance between their houses. And that's more realistic. Could somebody walk 1.6 kilometers? Yeah, they could walk 1.6 kilometers. It's not 96. That's you misinterpreting the minutes and not retranslating it into hours. If the speed is in hours per kilometers per hour, your answer must be in hours. Remember, we solved for minutes. All right. Enough babbling by Smith. All right. We'll talk to you later, grade 9s. Hopefully that helped. I know it's a complicated question, but there it is. Practice it. Okay? Just give it a shot. See ya.